Okay, we're going to pick up on page 11. A lot of the stuff we're going to see today, you guys have seen before, either in geometry or in middle school. We haven't talked about them yet in Algebra 1, but these ideas should be familiar, okay? So the first thing we're going to talk about is how to take a sort of a rule or a description and use it to create a function. So that's what we're looking at to start with on page 11. So we have a set of rules here, and we're going to match them to the appropriate function. So for A, so to get the output, subtract 7 from the input, then divide the result by 3. Which of these functions would match this rule? Okay, K of X, subtract 7 from the input, then divide the result by 3. These order words, then, is the one we're going to see a lot here. Those are important, okay? Those tell me about order of operations, right? What I want to do first, second, third, so on and so on. B, to get the output, subtract 7 from the input, then multiply the result by 3. The second one, subtract 7 from the input, then multiply by 3. So I want to do this first, then this. So that would be B. G of X is B. How about C? To get the output, multiply the input by 3, then subtract 7 from the result. Go ahead, any of you. The first one, then subtract 7. So multiply by 3 first, then subtract 7. And D is going to be hard, right? It's going to be the third one. To get the output, divide the input by 3, then subtract 7. Okay. You guys have seen this before, yeah? Yeah. Okay. You've done this before, probably in middle school, right? We're going to take this sentence in words and turn it into a sentence in math. You've done this before. So now let's kick it up to our sort of function land where we've been working. I want to know which of these functions has an output of -3 with an input of 6. Remember, output is our y value and input is our x value. So how can I determine an answer to this question? What could I do? Which of them would give me -3 if I input 6? What could I try here? Well, I want to know what to do. How do I figure out which one it is? Yeah, plug in x equals 6. You guys have done this before. So that's what I'm going to do for each of these functions. I'm going to plug in x equals 6. So I'll have f of 6, which means I'll take 3 times 6 and then subtract 7. I'll do g of 6, which means I will take 3 times, in parentheses, 6 minus 7. I'll find h of 6, which means I'm going to take 6 and divide it by 3 and then subtract 7. And I'll find k of 6. So I'll take 6 minus 7 and then divide by 3. So I'm going to plug in 6 for each of these and then simplify. Remember to follow order of operations here. So for f, I'm going to start with 3 times 6. That gives me 18. 18 minus 7 is 11. That's not the output I'm looking for. For g, inside parentheses first, 6 minus 7 is -1. 3 times -1 would be -3. That's the output I'm looking for. So function g would give me that output if I input 6. For h, 6 divided by 3 is 2. 2 minus 7 is -5. And then for k, 6 minus 7 would be -1. -1 over 3, I'm just going to leave as -1/3. So neither of these either, just g. Does that make sense? And you guys have plugged in values for a variable before. This is not new. Okay. one of the first times we've done it in Algebra 1, but it's not new to you. For number 3, which value of my functions is greatest when the input is 0? How would I figure that out? Exact same thing I just did, except for this time I'm going to plug in x equals 0. So I will figure out f of 0 and g of 0 and h of 0 and k of 0. I would like you to do that for me now. Plug in 0 for x and simplify for each of our functions here. Scoop my paper up so I can see my functions. If I plug in 0 for x, that would be 3 times 0, which is 0. And then 0 minus 7 would be negative 7. If I plug in 0 for x in g, that would be 0 minus 7, which is negative 7. 3 times negative 7 would be negative 21. For h, I would have 0 divided by 3, which is 0. 0 minus 7 is negative 7. And then for k, 0 minus 7 is negative 7, so I would have negative 7 over 3, and I'll just leave that as negative 7 over 3. So which of these is the greatest function value? Okay, yeah, this would be negative 2 1/3. That's the biggest of all these numbers. K would give us the greatest function value when the input is 0. We're going to skip 4 for now because it asks us to essentially do the same thing we just did twice. We would just be plugging in x equals 10 there. So I'm going to skip that one for now. And I want to hop down to our challenge problem. It says, is f of x always greater than g of x? So if I take a look at f of x and g of x, f of x, my function value for the same x, was bigger, f of x was bigger when I plugged in 6 and when I plugged in 0. I want to know, will that be the case for every value I could possibly put in for f of x and g of x? Who thinks yes, f of x will always be bigger? Who thinks no, it won't always be bigger? Who thinks, honestly, Miss Lucia, I don't really know. Okay, there we go. There are my honest hands. Okay, so let's take a look at this, okay? So let's pop up here to f of x, now that I've scribbled over it, right? This said 3x minus 7. That's mx plus b, right? That's a line in slope-intercept form. Now, g of x is not in slope-intercept form, but if I distribute the 3, I could get it in slope-intercept form. So that would be 3x minus 21. What do you notice about the slopes here? They're the same. What do you notice about the y-intercept? They're different, right? This y-intercept is much lower than this y-intercept. So if I were to think about the graph of these, they're going to have the same slope, right? Lines with the same slope. We have a special name for it. What do we call them? Parallel, yeah. So I've got parallel lines. One of them has, oops, that's not a good line. Let's switch colors here. One of them has an intercept, let's say that's negative 7. Okay, so this would be F. And then the other one would have an intercept at negative 21. We know they're not going to intersect because they're parallel lines. Okay, so let's think about for any input I could have, for any value of x, right? So if I pick right here as my value of x, my point on f of x is going to be higher than my points on g of x. Does that make sense? My point on line f would be higher than my point on g. If I pick a value over here, my point on f is higher than my point on g. Is that fair? Even if I pick a negative value for x, actually looks like this guy, my point on f is going to be higher than my point on g. So is my function value always going to be greater for f? Yes, right? Because that line sits up higher than my line for g. So this like plugging in value stuff, we can also relate it to the graph. I can think about it in those visual terms too if I want. Questions for me so far? Okay. I would like you to hop to page 13. We're going to come back to page 12, but I want you to hop over to page 13 for me for just a minute. Okay. So on page 13, we have a couple of problems where we're going to do the same thing we just did with our f of x, g of x, h of x, k of x. This time we've got b of x. We've got a new function here. If I want to know the output, the function value for b of 6, what would I do? Yeah, plug in 6 for x, right? Plug in x equals 6. That's exactly what you just described to me. So I would take 10 times 6 plus 25. So this would be 60 plus 25, which would give me 85. So b of 6 equals 85. Now, what if I don't know the input, but I know the output? So we've done things like this with a graph and with a table and with a sort of input-output map. We haven't done it with a function yet in here. You've done similar things in other classes, but we haven't done this in here. What do you mean by do it in reverse? So what I'm going to do is set this equal to 93. And then I'm solving for x. You guys have solved for x before. That's what you spent a lot of time in geometry doing, right? You set stuff usually equal to 90 or 180, and then you solve for x, okay? That's what we're doing here. So if I have the output for a function, I'm going to set the function equal to that output. And then, as you said, we kind of we worked it in reverse, right? Kind of reverse order of operations. I'm going to start by subtracting 25 from both sides. I get 10x equals, this would be 68. Divide both sides by 10. And we get x to be 6.8. So my input here had to be 6.8. You guys try D. Try D. Check your work when you're finished. You may have needed to pull out the calculator on this one. That's okay. Questions here? Okay. And then let's hop down to the bottom of page 13, problem number 4. Again, a little refresher review of stuff that we've seen before. So input outputs with the graph. Again, you guys have seen this before. So if I have f of 0 and I want to know what it's equal to, what is f of 0? Yeah, this is telling me my x value is 0. So here's where x is 0. Follow it to your graph. And your y value is 1, 2, 3. So f of 0 is 3. What about f of negative 3? Your x value would be negative 3, 1, 2, 3. Follow it to your graph. And that y value is positive 1. What about D? F of what equals 5? This is telling me my y value is 5. Follow it to your graph and give me your x. That would be 5 here. And then for E, f of what equals negative 1? I heard somebody say it already. So this means my y value is negative 1. Now we looked at a homework problem like this the other day. So I've got a point at 1 here. But then I also have a point when x is 3. I've got two values. Technically, I have a whole string of values in here. Alex, what were you going to say? Yeah. So if I've got more than one input that matches, put the inputs that match. We're just going to put the ones from the points, but technically I would have everything in here. So I would have 1 and 3. If I've got more than one, put all the ones that match. And again, we did this the other day. So now I would like you to flip back to page 12. We're going to look at one more thing for today. Kind of going back to those function sort of rule relationships. So we wrote a function from words, from a rule. Now we're going to write a function from a table. Okay. So for our first problem here, it says a square has a side length of 9 centimeters and an area of 81 centimeters. How do we find area? Length times width, right? So for some quadrilateral, I take the length and multiply by the width, and that gives me the area. What's special about a square? All sides are equal, right? So the length and the width are the same. So instead of using length and width, I'm just going to use S for the side length, right? All the sides are the same. So that means when I find the area of a square, since my length and width are the same, it's just whatever that side length is times whatever that side length is. Does that make sense? Since these are going to be the same number? So does it make sense if our square has a side length of 9 that the area would be 81? 9 times 9, right? Perfect. Okay. So now, what if I have a square with a side length of 1? What would be my area? 1. What if its side length is 2? 4. If its side length is 4? If its side length is 6? What if its side length is S? Very good. S times S, we could write as S squared. So if I want to leave it in sort of general terms, for whatever my side length is for my square, I could say the area is going to be S squared, that side length squared. So now I can write a function based on this. So this says write a function A that gives the area of the square when the side length is S. So this would be A of S equals S squared. The area based on the side length would be the side length squared. Does that make sense? Okay. So A2, that's in our table. What is A2? It's equal to, A2 is equal to 4, right? What does this mean in the context of our problem? A of 2 equals 4. A square with a side length of 2. And then since we know what it's equal to, can you finish that statement for me? Yeah, a square with a side length of 2, and our label is centimeters, has an area of 4 centimeters squared. Perfect. A square with a side length of 2 centimeters has an area of 4 centimeters squared. Now let's do another little refresher and let's graph our table here. So when my side length is 1, my area is 1. So I'm going to plot the point 1, 1. And then I'm going to plot the point 2, 4. We've got 4, 16 and 6, 36. So those are all the points for my table. Can I connect these? Think about what it means if I can connect these. Could I have a square with a side length of 3? Could I have a square with a side length of like 4.2? Sure. So since these are continuous variables, remember that term from Unit 1, since these are continuous variables, that length and that area, we can connect our points here. I can have any value in between there so we can connect these. Can I throw an arrow on either of these ends? Could I have, which end? Yeah, I can have bigger squares, right? Bigger squares are okay. What about smaller squares? Can't get smaller than 0. So I'm glad you phrased it that way. Could I have a side length smaller than 1? Yes. Could I have a negative side length? No. And does 0 really make sense as a value here? Not so much. So I could come back this way a little bit, but 0 doesn't really make sense, right? If the side length is 0, then I don't really have a figure at all. Yeah, so don't put an arrow on this side. Yeah, don't do it. Don't put an arrow. We can have bigger square stuff. Okay, questions for me on problem 1? Okay, hop down to problem 2. This is the last one we're going to look at for today. We have a roll of wrapping paper that is 3 feet wide. So that means the tube that my wrapping paper is on is 3 feet. Does that make sense? Okay, pretty big tube of wrapping paper. Okay. Now, when I wrap something, I can pull out as much wrapping paper as I want, right? So my length can change based on what I'm going to wrap. So here's my tube of wrapping paper, right? I've got my tube of wrapping paper. And this end is 3. So they call it width. My width is always going to be 3, but my length can change. Does that make sense? Based on what I'm going to wrap? Okay. So let's say that I cut off a piece that's 2.5 feet long. Let's say I start with a value of 2.5 here. What would be the perimeter of the paper that I've got? How do I find perimeter? Let's start there. Add up all the sides, yep. So I'm going to have 3 and 3, and then plus 2.5, plus my other 2.5. So we'd have a perimeter of 11. Yeah? Okay. Now, I can change this, right? The next present I wrap, maybe it's not as big and I don't need 2.5 feet. What if I only need 1 foot? What's my perimeter then? Yeah, 3 plus 3, that's 6, 7, 8. What if I use 2 feet? 10. What if I use, let's hop down to 11. What if I use 11 feet? 28, yeah. What if I just want to leave it generic? What would my function look like then? So 3 plus 3 plus L plus L. So if it's always 3 plus 3, is it okay if we use 6 instead? You guys cool with that? And then plus L, is there a shorter way that we could write L plus L? 2L, yeah, it's 2 times L. So our sort of generic form here would be 6 plus 2L. So our function for this, our perimeter, based on the length, would be 6, because that's our tube length, right? 3 and 3 is how we got the 6, plus 2 times whatever the length is that I cut off. Does that make sense? Okay. Pages 14 and 15 for homework tonight, okay? So you are going to do another problem similar to this. You're going to do a table, write me a function, all that good stuff. You're going to do a little matching. Here's the rule. Here's the function options like we did at the start of class today. And then you've got some input output stuff like we did on page 13. Okay, so 14 and 15 for homework tonight.